friends, welcome back to Learn with Ansh. My name is Ansh and in this video we are going to be discussing about chapter 10 Basics of Geometry exercise 10.2 of the book New Perfect Composite Mathematics Class 6. So the first question, which figure is an open curve? Now we have to find the figure which is an open curve. In real life, curve means something which is round, right? But in mathematics, curve can also be straight lines. So, what is an open curve? Let's discuss about this one. So, an open curve is basically a straight line or some straight lines or some curves. But let's say I draw this, okay? Now over here, we have this as a starting point. And now when we travel through this, we don't come back to the starting point. Instead, we end up in another point. So this is an open curve. Okay. Now, let's say I have this. Okay. So here, let's start at this point. Now I'm going to travel through it. And I end up at the same point. That means this figure is a closed curve. Okay? So now we have to find a figure which is an open curve, not a closed curve. So this figure, let's start over here. We go through this point like this, and we end up at that point where we started. So this is a closed curve and it's not a correct answer. Now let's check this. Now we start over here, we travel and we end up at that very point. Okay, so this is also a closed curve. Now let's check this. Now we start here, we go through the line and we end up at a different point. That means this is an open curve. Now this is a circle. Now I'm going to start at this point. And let's go through this and I end up at that very point where I started. So this is also a closed curve. Now, the third one is an open curve. So this will be the right answer for this question. Second question, which figure is a closed curve? Now they are asking for a figure which is a closed curve, not an open curve. Okay, so let's check. Here I'm starting at this point. So when I go through it, I end up at that very point where I started. So this is a closed curve. Let's go to the second figure. So here I'm starting at this point. I'm going through and I end up at a different point. So this is an open curve and it's not an answer we are looking for. Now over here, let's start with this and we end up at a different point. So this is also an open curve. Now this curve over here and here also we start at a different point, we end at a different point. So this is also an open curve. Out of all these four figures, this figure is a closed curve as I start at a point and I end up at the same point. Alright? So let's move on to the third one. Which figure is a polygon? What is a polygon? A polygon is basically a closed figure, but it should have straight lines. It should not have curved lines like this or like this. Okay? It should only have straight lines. So let's check one by one. So let's check all the figures which have only straight lines. So this figure has only straight lines. So this could be a polygon. This figure has some curved lines like over here, over here, over here. So this cannot be a polygon. And this figure has straight lines too. So this can be a polygon. And also this figure. This also has straight lines. So this can also be a polygon. Now, we found all the figures which have straight lines, but also there should be the figure should be closed. So let's try. So this one I'm starting at this point and I end up at a different point. So that means this is an open figure. Now over here, I start at a point and I end up at that point. So this is a closed figure, and this one again is an open figure. So the answer we are looking for is the third one. Alright, let's move on. Okay, so here it says look at figure 10.39 and name any two adjacent sides, 3 points on the polygon, 1 point in the interior, 2 points in the exterior, the polygon, 2 vertices. So let's go through each and every single question and we'll discuss about the new topics. So the A bit, 2 adjacent sides. So we need 2 adjacent sides. What are adjacent sides? So any 2 sides which are connected, like which are beside each other, are adjacent sides. So over here, we can say that this and this, these both sides are adjacent to each other, right? Line segment AB and line segment BC, they both are adjacent to each other. So they're just asking for any 2 adjacent sides. We can take any 2. I'm taking line segment AB and line segment BC. There we go. That's the answer for this question. Now, we need to name 3 points on a polygon. Okay? So, any 3 points on the polygon. So, on the polygon, which means on this line over here, any 3 points. Okay? Any 3 points on this polygon. So, we can say A, B and C, right? There are any 3 points on this polygon. So, point A, point B and point C. Okay? Now, 1 point in the interior. So what does this mean, interior and exterior? So to make this simple, we will draw a simple figure. Okay? Alright, let's take this figure. Okay, it has, imagine that this has 1, 2, 3, 4. Just ignore this small line over here. So it is a closed figure and 4 lines. So now we have a couple of points here, 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 here. Of course, all these 4 points will be there. And couple of points inside and couple of points outside. Okay, now we are not going to name these points for now. So here the points which are inside are called interior points. Okay, and the points which are outside are called exterior points. Okay, so the points which are inside are interior and the points which are outside are exterior. Interior means in, so in, interior, in. So you can remember it that way. And exterior, it's just the opposite of interior. And on, which means these 1, 2, 3, 4 points. Okay. So now they're asking 1 point in the interior, in. So that means 1 point which is inside. So we have this point and this point. Okay, we have these both points. So we can write any one. I'm going to take point P. Right? So let's move on to the next question. 2 points in the exterior. Now they're asking 2 points in the exterior, which means 2 points which are outside. And there are only 2 points. Okay, so we'll write both of them. This is the answer for this question. Alright, now we have to name the polygon. So a polygon is named by its sides and by its points, the points which are on the polygon. So here we have A, B, C, D, E, F, G, H, not I, okay, just H. This doesn't go on till Z, only till H. So A, B, C, D, E, F, G, H, I, no I. There's no I. Okay. So we have, these are the points. So now we have to name the polygons. So we just write the same points, the letters. Instead, we don't write the commas. So without the commas, we have to write all of this to name the polygon. So it will be A, B, C, D, E, F, G, H. There's no I, J, K, L. I was going to write till Z. Okay. So, never do this mistake in exams. Okay. I know it happens sometimes. You just get totally engrossed in writing it and you end up writing the whole thing. Okay. So, don't do this in exam. This is a big mistake. Now, we need to name any two vertices. Okay, so any two vertices means any two points. So we can take C and D. Okay, right, let's move on to the fifth one. This is also based on figure 10.39. So how many sides does this figure have? So let's count. So 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides. The answer to this question is 8. Now, B bit. How many vertices does it have? 1, 2, 3, 4, 5, 6, 7, 8. 8. Again, 8 vertices. Are BC and GF adjacent sides? So, where's BC, BC, BC? Where are you, BC? Okay? And GF. No, they are not adjacent sides, but instead they are parallel sides. So the answer to this question is a big no. Now, is HG a diagonal? Is HG a diagonal? No. A diagonal will be something like this. Okay? HG is not a diagonal. So this is also no. Are AC and AD diagonals of the polygon? AC and AD. So, yes, they are diagonals of the polygon. So the answer is yes. Is A in the interior of the polygon? No. A is on the polygon. And with this, we have completed exercise 10.2. Yeah!